Now we're going to look at a very important issue. How large does the sample size need to be in order to achieve a desired margin of error? Now, the margin of error is z star, your critical value, times the standard error of p hat, square root of p hat times 1 minus p hat over n. And so you can see there's a relationship between the margin of error and the sample size. That's an inverse relationship. The margin of error varies inversely with the square root of n. And that means we can make the margin of error as small as we like by choosing a large enough value of n. If we make n bigger, this denominator gets bigger, this whole expression gets smaller in value. So you can reduce the margin of error to any size you want if you're willing to pay the price to have a larger sample. Okay, there's one problem with this though. In this formula right here, we need to use p hat, but we can't find p hat until we've drawn the sample. So we're not going to know what p hat is before we draw the sample, and so we're not going to be able to make the sample size decision, without that information. So we've got a problem there. We need to have a value of p hat in order to plug in there so we can solve for the value of n that we need. And there are two things we can do. One is you can use a value of p hat from prior research or experience. The Bureau of Labor Statistics, for instance, knows that the unemployment rate is going to be somewhere usually less than 10%. And so they can set their p hat to be pretty small. If you don't have a prior value, you have to use p hat equals 0.5, and that's the worst case scenario because that's going to result in the largest sample and to achieve a desired margin of error. So that's really the worst case scenario, and you'd like to avoid that if you can, but in a lot of situations you can't. Now this is a typical kind of calculation that people need to make if they're given a confidence level or they want to achieve a desired confidence level and they don't know they don't have a prior value of p hat to use, so they can use 0.5, and they want to achieve a desired margin of error, then they can figure out what n needs to be based on this. So if c is 95% and you want a margin of error of less than 3 percentage points, then you just solve this little equation or inequality right here for n. So you plug in the things that you know. For 95% confidence, z star is 1.96. Plug in 0.5 and 0.5 for p and 1 minus p, and then you can solve that inequality for n. It just basically involves taking the square root of n and moving it over there and then bringing 0.03 down underneath that stuff. And that simplifies down to about 32.6 repeating. It's 32 2/3, and when you square that, you get 1067.1 repeating. Since you can't have a fractional individual in your sample, you need to always round up to the next value. Even though this is closer to 1067, 1067 would not be a big enough sample size to achieve the margin of error that you want, so you have to round up to the next value, which is 1068. Another example. Suppose we want 90% confidence, and we know from prior experience that p hat is about 0.08, and we want a margin of error of less than 0.2 of 1 percentage point, that is less than 0.002. We can figure out how large our sample size needs to be. We just plug everything in that we have up here into our margin of error formula. We're going to use 1.645 for our z star for 90% confidence, 0.08 and 0.92 for p hat and 1 minus p hat, and we're going to solve this for n. So we're just going to rearrange it and then square both sides. So I brought the square root of n up to that side and brought that down below, and then I squared both sides, and I got n is greater than or equal to this, and that works out to be about 49,791 observations in the sample. That's a huge sample size. But this is the sort of thing that the Bureau of Labor Statistics does when they calculate the unemployment rate every month. They want a margin of error less than 0.2 of a percentage point, and so that their numbers are useful to people. And they need a very large sample in order to accomplish that. Typically, they use a sample size of about 60,000 households, and they have the Census Bureau go out and collect that data for them.